Hey students, welcome back. We're going to do section 3.3 of your chemistry book, and we're going to learn about conversions. Many, if not all of the rest of your chemistry days here are going to be dealing with converting things, converting from one unit to the other. So last time we learned about the need for being able to convert from one unit to the other and using our standard international units, meters, volume, our time in seconds, our temperatures in Kelvin or Celsius. And then eventually when we talk about quantities of atoms or molecules, we'll talk about moles. So just like if you travel to a different country, I know these days you don't travel much, but if you travel to a different country, you need to convert. You need to convert from one type of money to the other type of money. And we're going to do things called dimensional analysis. So first we have to talk about a conversion factor. Conversion factor is like the bridge. You can think of it as a bridge that takes you from one sort of units to another set of units. So I'm going to be dealing with a little bit of our drawing here today. So here's a bridge, here's some land, and you have over here, and let's say this is the U.S. and this is Canada, right? Canada. To cross into these two countries and say it's over a body of water, you need a bridge. Okay? Okay. And so likewise, to convert from the money of the United States into the money of Canada, you'll need some bridge to convert from the dollars that are used in the United States into the unis, I think is what it's called, that's used in Canada. So a conversion factor, I'll just put fact, is the bridge that takes you from one type of unit to another. Now you've used these before. So let's see. Yeah, take those away. All right, so that's what we're going to be doing today when we talk about conversion factors. Hang on just a moment. Let me get this rolling here. Make sure I don't go too long in my time. There we go. All right, so let's get back to this. All right, so a conversion factor is a ratio of equivalent measurements. So the ratios of 100 centimeters per 1 meter or 1 meter per 100 centimeters. You'll notice I can switch these around in any direction I want to. They're a fraction, but we can flip them upside down as long as the 100 centimeters per 1 meter, the 100 stays with the centimeters because that's a conversion. For every 1 meter, the 1 stays with the meter. So if I flip it upside down, 1 meter, 1 stays with the meter, 100 centimeters. You can flip these upside down depending on the type of conversion you're doing. So here's a 1 meter. Okay, that's 1 meter is the same length as 100 centimeters. I'm probably sure you can imagine that in your head, but they are the same distance, just expressed in two different ways. Just like the word yes is equivalent of that in another language, say Spanish is sí. It means the same thing, just expressed differently. Okay, that's what's called a conversion factor. And how you go from meters to centimeters is this conversion factor, that 1 meter per 100 centimeters or 100 centimeters for every meter. Okay, so the small number in the large unit, large number, smaller unit. So that's another way to think of it. The small number goes with the large unit and the larger number goes with the smaller unit. It's one way to think of it. I don't see it as incredibly helpful, but your book sure does. All right, so when a measure is multiplied by a conversion factor, the numerical value is generally changed, okay, but the actual size is not. So if I convert from 1 meter to 100 centimeters, my quantity here is 1 to 100, but the actual length that I've walked or measured is still the same length. It's just expressed in different units, okay? So the scale of the micrograph is in nanometers. So if I'm looking at something at the microscopic level, Okay, micrograph meaning a picture of the microscopic level, graph meaning picture or writing. Okay, so that is it's measured in nanometers. Okay, so 1 nanometer, 10 to the ninth nanometers is 1 meter. So 1 billion nanometers is 1 meter, or 1 meter is for every billion nanometers. Okay. So we're going to talk about dimensional analysis. Now, a dimensional analysis will help you in two ways. Are you actually getting the answer you're looking for? And it'll help you analyze, does your answer make sense? Okay. If you do dimensional analysis, this will help you out. So dimensional analysis is a way to analyze the problem just by using the units or the dimensions. Okay. It provides you an alternative approach to your problem solving. So the method I use with you, what you got, what you need, get her done. And then the last one is to check yourself before you wreck yourself. I know that's kind of old and corny, but the check yourself is to make sure if the problem is asking you to give a distance in meters and your answer is in seconds, well, that's a measurement of time. You've done something wrong somewhere. So we'll talk a little bit about that coming up here. Okay. So let's talk about this right here. So how many seconds are in a workday that it lasts exactly 8 hours? Okay. So excuse me, got the sneezes today. All right. So I'm gonna use my pen here. All right. Hang on just a second. I can't. There we go. All right. Let that go away. Here we go. All right. So this right here, how many seconds are in 8 hours? So this is what you got. Okay, this is the method that I teach you. You write down what you got, WYG. You know that exactly 8 hours, and you know that these are your conversion units. You know that 1 hour is 60 minutes and 1 minute is 60 seconds. So the question is, what they're asking is how many seconds are in there? So what I need, and this portion right here is what I need, what you need, WYN. What you need is seconds. That's what you're looking for. So we need to convert from hours to second. So first, a conversion factor. Let's see if you're how this one does it here. So go ahead and convert this out. So here we go. We start with what is known. Okay, we're going to start with what is known. And here's what is known, 8 hours. That's what we got, what you got right here. And now we're going to use what we do know is some relationships here between 1 hour, 60 minutes. So we're going to convert our hours into minutes. So we always write down what we got. So I'm going to kind of write this here, kind of work with you. Write down what you got. Okay, that's how I do it. I draw a little line here, and then I'm going to write down what I need next. I want to convert that into minutes. So I need to grab how would I use that? I use my conversion factor of minutes to hours. So I'm going to write that right here, 60 minutes for every hour. And so then my hours cancel out, just like fractions, they cancel out. Now I got it into minutes, but what I need is I need seconds. So I'm going to write down what I need right here. I need seconds. I'll write that at the top right there. So I know that also there are 60 seconds in 1 minute. All right, so what I do, my minutes cancel out just like they do right here. Okay, so 8 times 60 is going to give me 28,800 seconds, or put it in scientific notation, 2.8800 times 10 to the fourth. So this makes sense. Does it make sense that 8 hours would have a lot of seconds in it? That 8 hours produces a lot of seconds? This is the same amount of time. 8 hours, if you work an 8 hour shift, you've also worked 28,800 seconds. That's the same unit of time, but the number is different because you're going from a larger unit to a smaller unit. Okay. So that is one conversion factor we have here. Okay, so we'll go to this next one here. Let me make sure we get this guy to go away. There we go. Okay, here's another problem we have here. How many seconds are in an exact 40-hour work week? We're going to do the same process that we did here. Okay, maybe make our thing a little bit smaller so we can fit it a little easier. Okay. So we write down what we got. So we got 40 hours, and we want to know how many seconds are in a work week. Let's double check that. How many seconds are in a work week? Okay, so we'll go ahead and start that. All right, so we have 40 hours, and we know that we're going to go that into minutes. So 60 minutes, write down what we need, and that is 1 hour. Okay, and then we convert. Now we got to get down to seconds, so we write seconds here, and we know that there's 60 seconds in 1 minute. Okay, and then so we would multiply 40 times 60 times 60. And that's going to be 1,144,000 seconds in 1 week, or 1.44 times 10 to the 1, 2, 3, 4, 5, 10 to the 5th seconds. Okay? So it makes sense that a 40-hour week would have a lot of seconds in it. Okay? Have a lot of seconds in it. So I hope that makes some better sense to you as you're doing conversions. Okay? So it's a little bit of our conversion analysis. So here's what we're going to do here. We're going to try another one here. Okay? So let's do a dimensional analysis problem that actually involves some chemistry. Okay? So we're going to involve some chemistry in this one here. Okay, we're going to involve some chemistry. So the directions for an experiment ask the students to measure 1.48 grams of copper wire. The only copper wire available is a spool with a mass of 50 grams. How many students can do the experiment before the copper runs out? Okay, so what we need to do, what do we start with? So let's do some analysis here. Okay, what we got, here's what we got. Here's what we got right here. We got what you got. Okay, and what do I need is the number of students, what you need. Okay, so what we have 50 grams of copper, and we know that each student needs 1.8 grams. So how are we going to convert that? How will we convert that? We will. Here's how we do it. We would have our 50 students. This is what we got. We have 50 students. 50 students. And then each student, we're going to convert that to students, and our conversion factor is 1 student for every 1.84 grams of copper. So 50 divided by 1.84 is going to be 27.174 students. That now that we got to kind of deal with the real world, we don't have 0.174 of a student. So we round that down to 27 students. So 50 grams of copper will allow us for 27 students to take our lab. All right, so we round to a whole number there. I hope that is helpful for you. And what we're going to do is we're going to stop the lesson here for today. So thanks so much for your attention, and I'll see you soon. Bye-bye.